For decades, the internet functioned as a massive listed catalog. We typed queries, and algorithms returned pages of blue links. That structure is now collapsing into a single point of synthesis. This graph illustrates the trajectory. By 2026, Gartner projects a 25% drop in traditional search volume, represented by this descending line, while conversational AI queries sharply accelerate. In the legacy model, users evaluated 10 distinct websites to find an answer. Today, AI engines read those sites simultaneously and generate one unified summary at the top of the page. This creates a strict winner-takes-all environment for digital visibility. If a system like ChatGPT, Claude, or Google AI Overviews does not select your specific data for its final synthesized response or place your link in its footnotes, your organic traffic disappears. Adapting to this environment requires Generative Engine Optimization, or GEO. Traditional SEO was built to help web crawlers index and rank entire pages. GEO is designed to help large language models extract specific data points. Generative engines do not treat a web page as a final destination for a user. They treat it as a quarry of raw material to be mined. To ensure their synthesized answers appear legitimate and trustworthy, these models are structurally programmed to back up their claims with footnotes. Survival in this ecosystem means structuring your data so precisely that the underlying mathematics of the language model are forced to cite your content over millions of competing sources. When a prompt is submitted to a generative engine, it does not execute a simple keyword match. This flowchart maps the engine's hidden four-stage pipeline. The first stage is query fanout, where the initial user prompt immediately divides into multiple concurrent search pathways. The model breaks a single complex question into a dozen smaller subqueries to gather a broad, contextual understanding of the topic. Stage 2 is information retrieval. Here, the system extracts exact paragraphs, data points, and code snippets from the pathways it opened. During this extraction, the engine actively strips away traditional structure, like heavy design elements and navigation menus, isolating only the plain text and raw markdown data. Stage 3 is synthesis. Those isolated blocks of pure data converge into a central processing node. The large language model blends and rewrites these disparate inputs, reconstructing them into a cohesive conversational output. Finally, the model executes the citation stage, attaching source footnotes and outbound links to the specific claims within that synthesized text. Every single piece of digital content created today must pass through this exact four-stage computational gauntlet. If you understand this pipeline, you can engineer content specifically designed to survive the extraction process and guarantee a position in the final citation phase. Researchers from Princeton University and Georgia Tech isolated the exact variables that secure those citations. Their findings were published at the 2024 ACM SIG-KDD conference. They established a benchmark called GeoBench, running 10,000 diverse user queries to measure exactly how content structure influences an AI's likelihood to cite a source. The study revealed traditional search tactics, like high keyword density, actively fail in a generative environment. This data table tracks the optimization strategies that actually work.
First, adding authoritative outbound links, citing peer-reviewed studies or trusted external data, results in a 30% visibility boost. Second, replacing vague claims with hard, verifiable statistics yields a 32% increase in citation likelihood. The most effective variable is the inclusion of direct quotations from industry experts, which increases visibility by 41%. These three elements, external citations, strict numbers, and expert quotes, function as high-signal trust markers during the engine's parsing phase. By deploying them, you trigger the AI's mathematical attention mechanism, prompting the model to prioritize your content above generic, unstructured text. This empirical data directly aligns with the framework of experience, expertise, authoritativeness, and trustworthiness, or EEAT. Generative engines require EEAT signals because their primary operational vulnerability is the tendency to hallucinate false information. To compensate, these models are tuned to behave like strict academic reviewers. They penalize unverified, heavily commoditized text. They prioritize unique human nuance, specific expertise, and original research because those elements cannot be accurately hallucinated by the model itself. You also have to present this expertise cleanly. Using markdown tables, structured bullet points, and concise executive summaries
allows the crawler to ingest your arguments without friction. Injecting these verifiable signals elevates a web page. It transitions the content from easily discarded data into the foundational bedrock the AI uses to construct its answer. Because the architecture of search has changed, the tools used to measure success must also change. Tracking legacy metrics like landing page clicks and search impressions provides an incomplete picture. This dashboard visualization shows the new primary metrics of digital performance: share of answer and citation rank. Specialized industry tools now track exactly how often a specific brand or dataset is included within the conversational outputs of platforms like Claude, Gemini, and ChatGPT. For simple, factual queries, we are entering a zero-click reality. Traffic for commodity answers, like definitions or weather updates, will vanish because the AI provides the answer instantly. However, users searching for deep technical guides or high-value commercial products still rely heavily on source verification. They click the AI citations to audit the information. Establishing a permanent, trusted position within a model's parametric memory guarantees that when those users click to verify, it is your system they enter. We are already moving beyond passive information retrieval. The next evolutionary phase of these platforms is agentic search. Soon, autonomous AI agents will operate across the web at high speed, evaluating pathways and executing secure decisions without requiring human input for every step. Instead of returning a list of options, an agent will compare competing prices, check real-time inventory availability, and execute the final transaction directly within the chat interface. These agents are bound by their architecture. They can only execute transactions using data they can successfully parse and definitively trust. Structuring your digital infrastructure for generative engines today is the absolute technical prerequisite for commercial survival in the agentic web of tomorrow.